Pre-calc FRQ numero dos. In case you don't know, I'm talking about number 2. Alright. A person purchased a car at the end of 2019. Oh, this is from 2026, by the way. This is the pre-calc exam that you just took, if you took it. Here, time 1, we have this value. Time 2, we have this value. Yeah. Oh, I need Desmos. Well, I don't need Desmos, but I want Desmos because this is the calculator section. So, Desmos College Board. This isn't College Board. This is. Alright, cool. So, we're given 2 values, and we want to make 2 expressions or 2 equations that we can use. The first equation is just going to be a... Well, I'm actually going to type it into Desmos. I think it'll be a bit better this way. First equation is just going to be ab to the power of 1 equals, because t equals 1, so that's going to equal 27,000, 27.2. Okay, cool. Next equation is going to be at t equals 6, we have 14. So a times b to the power of 6 equals 14.8. Cool. So these are our 2 equations. You write that down. That's part AI. And now part B we can do with Desmos with a regression. We know that when we plug in a 1, we're going to get a 27.2. When we plug in a 6, we're going to get a 14.8. And we know that this equation should look like a times b to the power of, in this case we know it's t, but we wrote them in under the x1 column, so it's going to be x1. And that is going to equal y1. So it's telling us that a is going to be roughly 30.27 and b is going to be this. If you recognize the pattern, you'll also recognize, hey, that's just an exponential. So it'll also, you can click auto regression, do exponential, and you'll get the same values here. So yeah, that's our decimal approximation. Now let's look at part B. Use the given data to find the average rate of change of the value of the car. Okay, we're looking for average rate of change from what? 6 to 1. So all we want to do is the first we want to write is our difference quotient, and we know our function is called v of t. So we need to write v of 6 minus v of 1 divided, all of this divided by 6 minus 1. Next, we want to plug in our values, or just tell Desmos, hey, we have this equation, and it's going to represent v of x. We could actually say that, hey, this is v of t, and I think we will. We'll go by. I'm going to change this x to a t just so Desmos knows what's happening. And my answer here is negative 2.48. So that's my answer. Use the average rate of change to estimate the value of t equals 3. So now this is my rate of change. I know that my So I'm estimating it at 3, knowing that this is my slope. So I should have y equals my average rate of change of this, which I can just copy paste, x, plus my y-intercept, which is going to be, I don't actually know. Okay, 30.7206. 30.7206. Right? So now this line is going to take our slope there and give us an estimate. But we want to say we want to approximate it when x equals 3. So that my estimate is 23,000, which is actually an overestimate. Yeah, the average rate of change, but, I mean, this is our answer. The average rate of change found can be used to determine the secant line from there to there. Let A represent the estimate using the secant line. For A of 3, it's found that the estimate's always greater. Use the secant line in the graph to explain why. Okay, well, let's look at the secant line. Instead of 3, this is just x. Notice that between, 0 over here and 6, which is actually a little bit like right here, notice that our line is always above. Our secant line is always above because our curve is concave down. So, yeah, the secant line is greater. Secant line is greater than the v of t. So a of t is greater than v of t on the interval from 1 to 6. So yeah, it's always going to be an overestimate. Because the line's always above, it's just always going to be greater. When the value of the car reaches $2,000, we want to donate it to a mechanic school. The car will immediately lose all of its value. Explain how this information can be used to determine a domain limitation for the model Y. So, range is Y values and domain is X values. We know we want to find what X value will the car reach 2,000, and assuming we follow this curve, we can actually add a line for Y equals 2,000. It's 202,000. Oh, sorry, 2,000. And I forgot the function was already in thousands. So when this equals 2, we just stop. And that's going to happen after 22.4 years. So after 22.4 years, we're just going to lose all of our value and the car's not going to be worth anything anymore. What that means is there's after 22.4, so we'll call that 23 years. We'll round up because you can't, yeah. After 23 years, the car will lose all its value, so we won't need to keep doing the domain. The domain will stop after 23, and that's why that works. Explain how this information can be used. Once the year, okay, after the car reaches $2,000, there is no need for the domain to continue, as the car will lose all its value. So, yeah. That's it. Bye, guys.